Dr. Pat here, looking at matrices. We'll be looking at how to add and scalar multiplication, which is basically a formal word for saying we're going to take matrices and multiply them by a number. All right, so let's get to some terms. Our first term that we're looking at is dimension. That's the number of rows and columns that make up the matrix. And how we list those things, we always list the row first and then the column second. If you want a way to remember it, kind of dorky, I admit, but RC Cola. So R is listed first, and then the C is listed second. And so that's just to remember row, column, row first, column second in our numbering system. Here's an example of a matrix. It's titled A. It's got its name, is capital A there. And this is a matrix. And so the question is, what's the dimension? And if we go by the number of rows, we have 3. And the number of columns is 4. So our dimension would be a 3 by 4. This is a 3 by 4 matrix. Another term that we're looking at, the elements. These are the items that make up the matrix. Most of our cases will be numbers. There are some other things in there if you want to, but we'll be working with numbers in our business pre-calculus and calculus class. And so this is a formal way of listing it. So basically, a capital A is the name of the matrix. It's the formal name. As we get inside of the matrix, we get a little bit more informal. And so just think of it as the small letter, and the lowercase letter. And what you're seeing here are these little numbers here along with the A, the small A's there. Those represents the position, and the position of a matrix is represented by the row number first and the column number second. Kind of just like how we list the dimensions. Kind of consistent that way. Thank goodness. Okay, so now let's just do a quick example of this matrix A here that I've given you originally. And so then what is the element 2, 4? 2, 4 here represents the position. And so we'd be looking at row 2, column 4. So when we go back up to this matrix, row 2, column 4 right there looks like it's the number 8. So 8 is the element of this matrix at the position 2, 4. So row 2, column 4. Okay, so now we've got some terms. Let's do some things. So now I want to look at how we can combine some matrices. But before we actually get to the abstract matrix, I just kind of want to look at this chart here. How would you do a new chart combining these two sales for these 2 months? So I got November sales, I got December sales at my little coffee shops at 3 different locations here, and I'm just looking at my big sellers of lattes, mochas, and Americanos, and I've got them for each month. If I want to know, hey, how was business for November and December together? How would we do that? So if you took a moment and you actually did that, let's see what happens. So go ahead and take a moment. Give me a chart that has the combined sales. Hopefully when you're doing this, you have the two. You have the sales for November. You have the sales for December. And these are the 2-month combined sales. And basically, what did I do? Well, for that very first column, the number of lattes at Edmunds, well, I took the number of lattes in Edmunds there in November and the number of lattes at Edmunds in 132, and I added those together and put them in the spot that says Edmunds lattes. And so notice that each spot in this matrix here of these charts are basically representing a particular thing. So the first row, first column represents Edmunds sales of lattes for the 2-month period there. And so each of these things, each position has a meaning. So like if we were looking at Linwood mochas, and that's the row 2 second column of this chart here, we would take row 2 second column of that chart, and then same thing with this chart, and we'd put them together. And then if we were looking for Everett lattes, we would take the information from the first chart about Everett lattes, take the information of Everett lattes in December, and then add them together, and we consistently do that throughout the same chart. So when we're looking at a business example, it's making sense that, hey, when you combine 2 charts together for combined sales, something like that, you want to make sure that you're using the appropriate information. The information matches up perfectly. When we're talking about Americanos at Linwood, then we're basically better be using the 3rd row, 2nd column numbers. 3rd row, 2nd columns, our charts match up, and we're able to combine them together. Okay, so now if you're the king of the world, how would you add the following 2 matrices? It has nothing to do with a chart, just basically matrices in themselves. how would you put them together? Hopefully you're thinking to yourself, dude, just like the chart, if I want to put these two matrices together, what I'd do, I'd add numbers in the same spots. And that's what we do. So to get this 8, what did I do? I added the 3 and the 5 both in the 1 1 position, first row, first column. I'd add them together and put it in the result in the first row, first column. For all those things that are in the first row, second column, I add those two corresponding numbers and put the result in the first row, second column position. For that second row, in that first column, I add the two numbers that are in the first row, the second row, first column, and I put my result in the second row, first column. And then our last thing to do is our 4 and our 2, they're in the second row, second column position. You add those two numbers together. I'm not adding the 2 and the 7 together. No way, they're in the wrong position. Would not add those. It's all about adding like things, and these positions have some kind of meaning for us in a real application. So I only want to add the 4 and the 2 together and put it in the appropriate positions. All right, another example. I've got a little trick question here. Not sure if it's a trick question or not, but hey, if I told you it's a trick question, does that still make it a trick question? I wonder. But hey, let's get back to the problem. How would we add these two matrices together? Okay, so if you're looking at those two matrices, how would we put them together? And the thing is we don't. These two matrices do not go together. Why? Because we're not allowed to add or subtract matrices. They need to be in the same dimensions. Whoops. Did I say that right? To be able to add and subtract matrices, they have to have the same dimension. So basically, our first matrix here is a 2 by 2 matrix. Our second matrix is a 2 by 3. It has 2 rows, 3 columns. And because we do not have the same set of numbers, yeah, sure, the 3 and the 5 can be combined together. That 6 and 3 can go together. But who's the 8 going to go with? Come on, I'm telling you, it's like going to the prom without a date kind of idea here. The 7 can match up with the 9. The 4 can match up with the negative 4. But the 2 right there doesn't match up with anybody. Oh my gosh, I think this is back in high school when I didn't have a date for homecoming. Oh my gosh, that's terrible. What a bad example of that. Hey, okay, so I just wanted to talk about those. Let's stop here and we'll do some scalar multiplication in a few moments. Thanks. Talk to you later.